All right, let's talk about something that could totally shake up how we use AI in medicine. There's a new model on the block, and it's built to read medical scans faster and way more efficiently than ever before. This is some really cool stuff, so let's dive right in. Okay, so let's just start with this big question right here. What if an AI could look at a medical scan and give a diagnosis that's not just faster and cheaper, but also more accurate than what we have now? Think about it. A doctor getting a super-powered second opinion in like seconds. It sounds like sci-fi, but trust me, this is happening right now. So, how does this magic work? Well, the core idea is something called multimodal fusion learning, or MFL for short. Instead of teaching an AI to just look at an MRI or just a CT scan, you teach it to be a master of all of them. It learns to look at an MRI, a CT, and an X-ray, all at the same time, and then it fuses all that information together. It's like giving it three different sets of eyes to get one super complete picture.
Okay, the idea sounds amazing, right? But there's a catch. Or actually, two big ones. Putting this into practice has been a real headache for scientists, creating a pretty serious dilemma.
And here is the heart of the problem. You've got this incredible promise, right? AI giving us lightning-fast, almost superhuman diagnoses. But then, the reality hits. The models that can do this are just massive. They're computational monsters. That means they're slow, they're crazy expensive, and this is the really bad part, they can actually lose some of those tiny but critical details in the process. Something had to change.
And this is where our hero enters the scene. Say hello to EDFnet. It's a brand new framework designed specifically to break through those walls of inefficiency and inaccuracy.
So what is EDFnet? Well, it stands for Efficient Dual Domain Fusion Network. And honestly, those first two words, efficient and dual domain, are everything. This thing was literally built from scratch to solve that exact problem we were talking about, how to be incredibly smart without being a slow, clunky beast. Yeah, this quote from the paper just nails it. The whole point wasn't to just chase power or just to cut costs. The real genius here was doing both, getting absolutely top-notch performance while using the absolute minimum amount of computer power. That's the holy grail right there.
So, the big question is, how did they pull it off? Well, the secret is in the name, that whole dual domain thing. This is the clever bit of engineering that really sets EDFnet apart. Let's peek under the hood. Basically, it works in three steps. First, it takes each scan and kind of cleans it up, makes the data better. Then comes the really cool part. It intelligently smashes all that information from the different scans together. And finally, it does one last pass to enhance the combined image, making sure the final result is as accurate as it can possibly be.
Okay, the real secret sauce here is in that middle step, a module called ESFI. See, older models would process information one step at a time, like an assembly line, and at each step you risk losing a little bit of information. But this new module, it does things in parallel. It looks at the data from two different angles in two different domains at the exact same time. So what the heck are these domains? It's actually a pretty cool way to think about it. The spatial domain, that's like a detective on their hands and knees with a magnifying glass, looking at every single tiny detail, every texture, every little line. But at the same exact time, it's analyzing the frequency domain, which is like that same detective pulling out a black light to see all the hidden patterns and clues that you just can't see with the naked eye. EDFnet does both, simultaneously. In doing things this way, it's a total game changer. Why? Well, first off, you don't lose information along the way like in the old models. You get the super fine details and the big picture patterns all at once. And because it's so smart, it just slashes the amount of computer power it needs. The end result? A much, much more reliable diagnosis. Okay, all this theory sounds great, but does it actually work? You bet it does. The researchers put EDFnet through the ringer, testing it against the best of the best on 12 different medical imaging datasets. And the results? Well, they speak for themselves. First up, efficiency. Get this. EDFnet cut down the computational cost, we're talking raw computer horsepower, by as much as 75.7%. That isn't just a small improvement, that is a massive, massive leap forward. But here's the crazy part. It didn't get all that efficient by cutting corners on accuracy. No way. It actually got better.
It boosted performance by up to 1.8% over the other top models. So let that sink in. It's way cheaper to run, and it's more accurate. That's the win-win.
Let's break it down like this. You've got other models out there. M3AT is pretty good on performance, but it's an energy hog, low efficiency. Dear DINet is even better, but it's still just okay on the efficiency front. And then there's EDFnet. Look at that. Excellent and excellent. It's the only one that absolutely crushes both performance and efficiency. It's playing a whole different game. And if you're a visual person, this chart says it all. Look at that huge bar for M3AT's computational cost. Massive. DriftNet is an improvement, sure, but then look at EDFnet, that tiny little sliver. That's what we're talking about. A huge drop in the resources you need. This is what makes it practical for the real world.
Okay, enough of the techie details. Let's zoom out. What does this actually mean for you, for me, for everyone? Why is this such a big deal?
I mean, the impact here is just huge. We're talking about getting better, more accurate diagnoses for things like cancer, brain tumors, you name it. For patients, think about it. It means getting answers faster, cutting down on that horrible, anxious waiting. For doctors, it's like having a brilliant co-pilot, helping them make the best calls. And maybe the biggest thing, because it's so efficient, this tech isn't just for fancy big city hospitals anymore. It can be used in local clinics everywhere. That's huge for making great healthcare accessible to more people.
So really, that's what it all comes down to. This isn't just about one cool new piece of tech. It's about a whole new chapter for medical AI, one that's actually practical, affordable, and incredibly powerful. And it leaves us with this big question to think about. As tools like this become common, how is that going to completely change what a trip to the doctor's office looks and feels like in the future? Something to chew on. Thanks for tuning in.